Hi, in this video, we're going to look at how to verify OSPF v2. Okay, we do show IP protocols. We can see our OSPF 10 there. That's our process ID, the router ID, what networks we are routing for. Okay, those are from the network command, or if we enabled OSPF v2 on the interface, and who our neighbors are. All right. So another command, very useful command, show IP OSPF neighbor. First of all, one thing you may want to do is show IP interface brief. Make sure your interfaces are up if you're having problems. Make sure they're in the up and up state. Make sure you can ping your neighbors. Okay, if you can't ping your neighbor, if you don't have communications with your neighbor, then you're not going to be able to form an adjacency. So make sure that you can actually communicate with your neighbor. Excuse me. Make sure that you can form a neighbor adjacency. So you got to remember that the hello interval, the dead interval, and the network type must match, along with other information like MTU, the network. They must both you and your neighbor must be sharing the same network address. So looking at this information here, we could see that this column here gives us a list of OSPF neighbors, their router IDs, and this is the order they were learned. This is the OSPF interface priority for the DR-BDR election process. This here shows us that we are in full state. Okay, that means that our databases are identical, they are synchronized. Now, sometimes on a multi-access network where you have a DR, BDR, you're going to see maybe two-way here at times, and that's completely normal. Here's our dead time, the amount of time remaining before declaring that neighbor down for getting the next, we get hellos, so that'll be reset in this case, depending on what the hello intervals are. Here's our neighbor's IP address, and here's our local interface that we use, our egress interface, to reach that neighbor. Okay, verifying OSPF routes, we can do show IP route, and we can do show IP route OSPF, which will show us all our OSPF routes. If we want to see a specific route, we can just say pipe and include 172.16.2.0, and that will show just that line. That's what the include means. Pipe include means include anything with 172.16.2.0 in it from the routing table output. Okay, we can see our network there. We can also do show IP route 172.16.2.0 and get some more detailed information. In both cases, we see the administrative distance of 110, but the routing metric is 65. Okay, verify OSPF interface information. This gives us all kinds of good information, including the area, the router ID. There's our network type, point-to-point. That must be the same as our adjacent neighbor, which is R2 in this case. There's our cost on that interface, which is $647 for that specific interface. The cost $647. Hello and dead times, 10 and 40, respectively. Those must match with our neighbor R2. Okay, there's other information there, neighbor count, adjacent neighbor count, which is only 1, and our adjacent neighbor is at 2.2.2.2. Okay, we can see a lot of that, some of that information in the show IP OSPF interface brief command, okay, which shows us our interfaces, shows us the cost of that interface, which is determined by our reference bandwidth divided by the bandwidth in bits per second. Right. And show IP OSPF command, which gives us information about the OSPF process, including the process ID, the router ID, and some other information here. Some of this we'll talk more about when we look at multi-area OSPF. But we got information there that things like last time the SPF algorithm was executed and how many times it was executed. Cool stuff. All right, so that's the basics on verifying OSPF v2.